Hey kiddos, hope you're having a great day. We are going to move on to our last learning target today. So our last learning target is I will learn how to factor using different methods. So essentially factoring, that just means that you're taking something a little more complex and you're breaking it down into something that's easier to work with. So factoring is like my all-time favorite thing in math ever. So I'm super excited we're on this unit. If you need factoring help, please come to me. Factoring is something that does not go away. It is on the ACT a lot. We'll use it in the rest of class a lot. So my favorite subject, hopefully you all like it too. It's kind of like putting a puzzle together. It's a whole bunch of pieces. And once you get it together, you're like, oh, wow, that was satisfying. So there are there's tons of different types of factoring, but there's 6 different types of factoring that we're going to learn in our class. So as to not overwhelm you, we're going to take a couple days to learn them all to make sure we get good practice with them. But I am going to do 2 in a video, so that way we can do 2, practice, do 2, practice, do 2, practice, so on and so forth. These videos will be a little bit shorter than normal, but factoring is so important that we probably will have a little bit more practice than normal, so just kind of a heads up there. So I'm going to be making separate videos, but you can feel free to add these to just continue on in your notes when you're making them. So we're going to title our notes just factoring. Okay, let's see, what order do I want to teach these in? So let's do, I think it makes sense to do those 2 together, these 2 together, these 2 together. Okay, so we'll start off with GCF factoring. So GCF, or greatest common factor. I know you all know what greatest common factor means, because we've done it a whole bunch in bell work before. So GCF factoring, greatest common factor. So let's say, for instance, we're given 90x squared plus 27x to the third. So if we want to GCF factor this, so when you're doing different types of factoring, most of the time it'll tell you what kind of factoring it needs you to do, but greatest common factor, that's something that you'll eventually learn to just kind of recognize that if you pull something out, it'll make it a lot easier. That's what we did in our last learning target when I said we could factor out a 2. That was greatest common factoring. So this is just a way to kind of break things down to make it simpler for you to work with. So 90x squared plus 27x cubed, those are both big numbers. We kind of want to break that down. So you're going to first you're going to look at your coefficients. What can I pull out of both a 90 and a 27? And we want it to be the biggest. This is greatest common factor. Like, we don't want to say, oh, I can take a 1 out. Like, that's not going to change anything. We want to know what is the biggest factor we can take out of there. So if you're someone that's not good with your factor trees and things not really factor trees, but you're just factors, you don't really know your multiplication tables, this might be a little more challenging for you, but you can just do a lot of trial and error in your calculator. 90 divided by this is this. 27 divided by this is this. So factors of 90, we know we have 2 and 45. Neither of those go into 27. So it's not going to be that. It has to go into both. So that's the big key thing. So 90, we're going to have 3 and 30. So 3 works for this one, but I don't really think it's the biggest, or we could always try it and we'd be able to see if we were able to pull more stuff out if it was the greatest common factor. We have 9 and 10. That works for this one, and 9 times 3 is 27. So we're going to pull a 9 out, and then we're going to move on to our x's. If I have 2 x's over here and I have 3 x's over here, I have to sneeze. No, I don't. Yes, I do. No, I think it passed. What's the most amount of x's I can pull out? 2. I can pull out an x squared. So this is the biggest thing that I can pull out. When we're doing greatest common factor, we want to know what's also left over. So when I pull out a 9x squared, I can think about that as dividing. So what's 90x squared divided by 9x squared? That's going to leave me with a 10. Move over my plus sign. 27x cubed divided by 9x squared. 27 divided by 9 is 3. X cubed divided by x squared is going to leave me with x. Okay, so this would be your final answer. So let's say we didn't pull out the greatest common factor. Let's say we did pull out a 3. So we pulled out a 3x squared. And then 90 divided by 3 is going to give me 30. And then 27 divided by 3 is going to give me 9x. So this would not be correct because 30 and 3 both have something else in common. They both have another 3 in common. So then I'd have to factor that out again as 3x squared times 3 and then 10 plus 3x. So that would bring me back here. So you want whatever's inside your parentheses to not be able to be simplified down anymore because as you can see here, that's not the greatest common. I didn't pull out the greatest common factor if I can simplify it down even more. Okay, so make sure you are listening to the things that I'm saying because like if you go back in your notes, all you have is this and you're going to be like, huh. So write down little notes and tidbits about what I am saying. And let's do another one. We have 20 x to the 4th plus 45 x to the 5th. We want to know what's the biggest thing we can take out of 20 and 45. So for 20, we're going to have 10, 2, 4, 5. 45, we're going to have 9, 5. Yeah, just 9 and 5. So the ones they had in common there was going to be 5. We can pull out a 5. I have 4 x's here and 5 x's here. The most I can take out of both is going to be 4. And then what am I left over with? So 20x to the 4th divided by x to the 4th, 5x to the 4th is going to leave me with a 4. Plus 45x to the 5th divided by 5x to the 5th is going to give me 9x. So if we were to multiply this back out, we'd end up right back here. So this is just breaking it down. So if you're ever unsure about if you did something right, just distribute it back out and check to see if it matches up here. Sometimes you'll just be given all variables like so. Plus x to the 3rd y. You're not going to be doing this any differently than what we did up here. So we don't have any numbers to worry about. So we'll start with our x's. If I have 5 x's over here and 3 x's over here, the most I can take out is x to the 3rd. If I have 3 y's and 1 y, the most I can take out from both is 1 because I can't take 3 away from 1. And then I'm going to see what's left over. So x to the 5th divided by x to the 3rd is going to give me x squared because we're subtracting. Y cubed divided by y is going to give me y squared. X cubed y divided by x cubed y is going to leave me with a 1. So that's probably the biggest hurdle people have is remembering that if everything is pulled out, we're just left with a 1. Because remember, I want to be able to distribute this back out and end up right back here. So if I didn't have anything here, I wouldn't get this same result. All right, let's try one more. We're going to have x 4 y 3rd minus x to the 5th y to the 3rd z. So we'll go down the line, start with our x's. I have 4 over here and 5 over here. The most I can take out is 4. 3 over here and 3 over here, I can take out all 3. So this is the tricky part. If I have 0 z's over here and 1 z over here, I cannot take any out because they both do not have a z. So the z is going to have to stay. So now I'm going to have to do the same thing. 4x to the 4th y to the 3rd divided by x to the 4th y to the 3rd. If everything's taken out, it leaves me with a 1. Carry over my minus sign. X to the 5th divided by x to the 4th is x. Y to the 3rd, y to the 3rd. That's going to be a 1, but in this case, we don't have to have it because we do have that x there. And then my z follows. And that would be your final answer. Okay. So the next type of factoring is called difference of squares factoring. So this is one that is very, 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 very common on the ACT. So essentially, let's say we're given something like x squared minus 49. This is where knowing your perfect squares that we did last unit comes in super duper handy. So you're going to want to recognize that they both are perfect squares. And so by perfect squares, I mean that we can multiply the same number by itself. You all know what perfect squares mean. So we're going to have to recognize that. So difference of squares, difference, we're always going to have a minus sign. And then we're always going to have two terms. So if we had three terms, we would not be able to do this type of factoring. So we're going to recognize x squared. The square root of x squared is x. The square root of 49 is 7. So those are both perfect squares. So I'm good to go for doing this type of factoring. And then we're just going to simply do what I just said. The square root of x squared is x. The square root of 49 is 7. So we know we're going to have two x's and we're going to have two 7s because we're going to want to multiply them together to get right back to where we started. We always want it to be a negative number, so one is going to have to be negative and one is going to have to be positive. So I can break that down. X minus 7 times x plus 7 is going to give me x squared minus 49. Okay, so let's say we have x squared minus 64. 64 is perfect square, x squared is perfect square. So I'm going to be able to make my two parentheses. I'm going to have x, the square root of 64 is 8, and then one is going to be minus and one's going to be plus. So it doesn't matter which one comes first. So this is a super easy type of factoring as long as you can recognize those perfect squares, and you remember you have to break it up into two. So this can also take place if you have something that's just a little bit bigger. 36x squared minus 25. So this one doesn't look exactly like those two, but our first term is a perfect square because what's the square root of 36x squared? Hopefully you said 6x, and the square root of 25 is 5. So the square root of 36x squared we said was 6x, and square root of 25 was 5. One's going to be minus, and one is going to be plus. And that would be your final answer. So if you're ever unsure, you can always multiply it back out, and you should end up right back here. All right, well, those are the first two types of factoring. Not too many notes today. We're going to do a big bunch of practice, though. So if you have any questions, please reach out. Hope you all have a great day, and I'll see you when I see you.